This is eHobbyist Blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we will mount transformers to the enclosure. No, not that kind of transformer. Come on. Really? Okay, that's a little better. Now, one of the problems I had was to identify the transformers that I would require. Just concentrating on the external power supplies for the circuit being prototyped. I needed a secondary that would feed a regulator, giving me 0 to 20 volts, half an amp. Then I needed another secondary, independent and floating from the first, that would provide voltage to feed a dual tracking regulator going from minus 20 to common to plus 20. And then I needed a secondary that would provide current to digital external supply at plus 5 volts and plus 3.3 volts at 1 amp. I also needed to feed from the plus 5 leg the USB universal charger. I decided, okay, I'm going to go with independent transformers for the external power supply. As for the internal power supply, I was able to come up with a transformer that could provide enough voltage to feed plus 15 and minus 15 regulators, another winding that could provide well over 2.5 amps at a high enough voltage to feed plus 5. So I wound up with this conglomeration of transformers. The conventional shell-type transformer that would power the prototyping system internal power requirements, and then 3 toroidal transformers that would power the external power supplies available to the circuits being prototyped. The next problem is, given this conglomeration of transformers, where do you stick them? Oh, come on. As it turns out, it depends on your objective. I decided that the highest priority I had was panel space. This whole project is dealing with analog controls, buttons and dials and switches, and although I do anticipate at some point in the future convert to digital controls and digital controllers, at this point it's all analog, so I need as much panel space as I can get. And that meant positioning the transformers so that they would not interfere with usable panel space. So what I did was to position the transformers underneath solderless breadboard sockets, the prototyping matrix, and leaving all of the area to the left and right free for use by panel controls. So I printed off the template, taped it to the inside lower part of the enclosure to be used for center punching and subsequent drilling of holes needed. Some of the holes were required for mounting transformers, and on each corner were holes used to mount rubber feet. The ones provided with the enclosure by the manufacturer just weren't high enough, so I repurposed some rubber feet that lifted the lower part of the enclosure up by about 3/8 of an inch. Given the center punched lower half of the enclosure, the next order of business was to drill the holes. In this case, there are several different hole sizes required. The rubber feet require number 4 holes, so I started off with a number 4 body drill. Subsequently, other holes required number 6 screw for most of the holes, and then the toroidal transformers required holes that would accommodate number 8 screw. 2 of them required a weird off-the-wall bolt size, probably invented by metrics fascists. After drilling the holes, the next step is to deburr them, and I tried different ways of deburring this go-around. Initially with a reamer, and subsequently tried a rounded vanadium steel milling tool and a countersink attached to the electric drill. The countersink seemed to be the best alternative, although I'm still not satisfied with any of them. Having drilled all of the holes to their requisite sizes, my next order of business is to attach the rubber feet to the bottom half of the enclosure. Rubber feet require number 4 screws and associated hardware. Next, I need to scrape off paint around one of the mounting screws for the conventional transformer. This is going to be the site at which I'm going to attach chassis ground wire going from the top half of the enclosure to the bottom. And I need to scrape off the paint to make sure I have clean contact. Doing this with a screwdriver. There'll be a toothed lock washer going over this to make sure I have clean electrical contact. Now I'm going to start attaching the transformers, and for reasons that totally escaped me, I started with these toroidal transformers. I should have started with a conventional transformer. The reason is that the conventional transformer comes awfully close to that toroid transformer, and the space between them is not a whole lot. Proximity is annoying. It would have been a lot easier to assemble if I did the conventional transformer first. And we put a insulating washer, transformer itself, and then another insulating washer, and then the bell-shaped washer on top of that. Do it hand tight, and in this case I'm going to be tightening them up with a nut driver, I think. Ah, here it comes. Okay. Now those are the two main toroids. There is a third toroid transformer which did not come with mounting hardware, so I have to make some. What I have here is SAE number 8 threaded rod, and I'm just going to measure off the length required. And I'll be using a screw shears to cut that rod to a required length. Now the shears has a threaded portion for number 8, the screws, the other half a body diameter hole. And then when you exert pressure on the two handles, the rod will shear, or screw will shear cleanly and can be used directly on a nut. There's no filing required. So this is an amazing little device. I've never had it fail on me. Okay, here comes the shear. In order to convert that piece of rod to a usable screw, I'm using an acorn nut on one side of it. Tighten that up and then put a lock washer on it and a flat washer. We don't want the acorn loosening up. And now we have effectively a made-to-order screw to mount this particular toroid. Okay, let's get it on top there. Now, I had no mounting hardware, so I have to improvise the washers, and what I want to do first is to put some insulation on top. Remember the rubber washers for the other transformers. Well, lacking hardware, what I'm using here is electrical tape, so that whatever pressure is exerted is not being exerted directly on the transformer covering. Now I've got to do something about the washers, and I have no large bell-shaped washer, but I do have some larger washers. The holes on the larger washers are just too big, so I've got a series of 3 different flat washers. When brought together, they show the possibility of getting the job done. And on top of this, I have a lock washer and a number 8 nut. This idea of using threaded rod saves me from having to buy and store long-length machine screws. Mount the screw that is going to be one of the attachment points for the conventional transformer. Now I have a toothed lock washer. That upper portion is going to be the point at which I attach a chassis ground. Now comes the second screw, and here's the problem. My fingers don't fit into that area. And so I'm using this flexible nut driver, which can fit in there. Life would have been a lot easier if I did the conventional transformer first. Now I've got all of these transformers mounted. In this video, I created a circuit diagram and transformer panel diagram. I center punched, drilled, and deburred required holes, attached rubber feet to the bottom of the enclosure, removed paint from a connection point, establishing clean contact for chassis ground, improvised some mounting hardware for one of the transformers, and then mounted all the transformers to the enclosure. In the next video, we will be wiring the transformer primaries. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.